Okay, we're in homework 15. Certainly go to the whiteboard. Again, my emphasis over here for some students are looking at this. I'm just saying, what do I need to do? You need to study. You need to get good with the material, and you certainly want to be competitive. And the only way you can be competitive is by working hard and exercising. And that's why we give you exercises, and we want you to exercise. All right. You're going to see me exercise. Of course, I don't do as much studying as you guys over here. If you're doing more study than I do, you should be quicker than me. You really should. All right. And you're also younger than me. And I really do mean that. You should be quicker. So let's go to the homework. And I'm going to start doing it one at a time. All right. I'm going to switch to the whiteboard now. And I'm going to start doing homework. And I got a key over here. And again, when I'm doing homework, I'm not handing it in. I'm just, basically looking at this thing and say, can I do it? And can I do it quickly is really what I want to know. And what do I have over here? Y equals 4x7. What do they want to do? They want to compute the derivative. First one, second one, and third one. So y prime, 28, x6. That was easy. Y double prime. Well, that's going to be a tough one, right? 6 times 28. That's going to be 120. And 6 times 48, 168. X5. And then y triple prime. They want that too. We'll see if I can. I'll look at the key later. 5 times 168 is 500, 300, 800, 840. Yeah, you should have some basic arithmetic skills down. And now I'm going to grade myself. How'd I do? All right, good. Second problem number 2. One was easy. Hope everything's like that. All right, let's do this one. Same type of question. Looks easy to do to me. So, I know what y is. What's y prime? Fairly easy. That's 15x squared minus 16x. Let me point this out. If y prime is wrong, y double prime is going to be wrong. 30x minus 16 and y triple prime would just be 30. Let's get a red key out. See how we did. Bingo, got that one right. All right. This one says find the second and third derivative. Wow. Let's see if we can do that. And this is a function of z now. So z minus 3, z to the minus 1. I want to point out when they put y prime down, what does it mean? dy dz. All right. Let's put this down. What's y prime? It's 1 plus 3 z minus 2. What's y double prime? Minus 6 z minus 3. What's y triple prime? It's 18 z minus 4. Let me get my red pen out, see how we did. Did I get this one? I did. Did I get this one? I did. Now they write without negative exponent. You don't have to do that, but you can if you want. Let's go to 4. So far they've been pretty simple. And what's 4? Again, first, I get the first derivative, then second derivative, then third derivative. Let's write this down. Now, what I'm going to recommend you do is just simplify these guys over here. This would be 7 minus 7x minus 1. Now, someone's going to say, do I need to do that? No, you need to do what makes your life easy. This makes my life easy, by the way. What's y prime? Well, it's going to be 7x minus 2. What's y double prime? That will be minus 14x minus 3. What's y triple prime? That's going to be, 3 times 14, 30 and 12, 42, x minus 4. Let me get my red pen out. Did I do that? I'm seeing it, and I'm seeing it. I feel good about that. All right, let's keep going. Relatively simple questions. And, I say they're simple. You may say, no, these are not simple for me. Well, that's because maybe you haven't practiced enough. All right, I don't do much practice either, by the way. I'm not thinking about practicing and stuff. And that's something I want to encourage you that when I was an undergraduate student, I was typically faster than my teachers. And in almost all cases, by the way, for one thing, much younger. The other thing, my teachers weren't studying. They had no study at all. They weren't going home doing homework, right? They were just simply coming to class and talking about the material. I remember one chemistry teacher, a student in the room, this was during a recitation period, a student in the room said, could you do problem number blah, blah, blah on page blah, blah, blah? And the teacher looked at the problem and said, I'm stumped, I can't. And then what happened is, and these are large lectures, by the way, he said, is anybody in the room able to do it? And out of the 300 students, almost everyone raised their hand. Those students were go-getters. Let's go through this, all right? We want you to be go-getters too. So what do you get over here? Well, I got to do this over here. So let's write down y prime. And you can get better over time, by the way. Oh boy. Square the bottom. Bring the bottom to the top. Times root of the top, which is 0, minus the top, times root of the bottom, which is 1. So I get something pretty easy. I get minus 4 over 3 plus x squared. Let's just check ourselves. Did we get that right? Is this what they say it is? Bingo. All right. Boy, I got to keep going, don't I? I'm going to write a little differently. Let me try to use my skill set here. Let's go write y double prime down now. What does that give me? 8, 3 plus x minus 3, y triple prime. And you may be doing them differently. Minus 24, 3 plus x minus 4. Get my red pen out, see how we did. Got that one right. And got this one right. Let's keep going. Now I got to go to 6 now, next page. Same thing over and over again. And more derivatives. I'll be writing these down for you. Do one at a time. I want to see if I get their answers, of course, but I'll write down for you. And y prime. Let's see. I'm going to do, let's see, x6 times root of e to the x, which would be e to the x, plus the root of x6 would be 6x5 e to the x. All right, I'm going to factor it out. So what are you factoring out? I'm actually just going to factor out e to the x, by the way. And someone says, why is that? I want to get something simple to differentiate. And I don't want too many products, right? So it's going to be x6 plus 6x5. Let's see if we got that first derivative right. And I'm seeing that right over here, right? EX, x6. Yeah, I can do my second derivative now. Let's put this down for you. What would that give me? Well, e to the x times, I'm going to do the inside. It's going to be 6x5, right? Plus 30. I'm going to write this down. 30 what? 30x4, right? Plus e to the x, x6 plus 6x5. Again, I'll look at the key later, but I'm going to factor out e to the x. What would you go with there? I guess you get 12x5, right? We'll check the key later. Mistakes happen a lot, by the way. Plus 30x4 plus x6. I'm going to see if I got that right. I don't know. Maybe I didn't. I'm seeing this right over here. I got e to the x, and I got x6. A little different order, by the way. 12x5. Wow, I did that one right too. And that was the second derivative, right? I got to get the third one. Let's see if we can do that. Well, e to the x. Let me do the derivative of the inside now. Oops, sorry about that. Wow, 60 x4 plus 120 x cubed plus 6 x5 plus e to the x 12 x5 plus 30 x4 plus x6. Well, I still have a factor of EX in common. I got to add those terms together. Let's try to be a little orderly in this. I'm going to see 12x5. Let's do the fours. That's going to be 90. Ninety x4. I got that covered. 120. Oh, you know what? I think I didn't get something. I'm going to erase this because I got a little dizzy on this one for a second. I'll erase this over here. And I apologize. I'll start with x6. Let me do the x5 now. And I apologize for going so fast. And that's 18, isn't it? It's tough though. I'm not saying it's easy. Let's see, 90x4. And then 120x cubed. Wouldn't be the first time I made a mistake. Let's take a look. See how we did. It's tedious, right? E to the x, x6, 18x5, 90x4. Wow, we got it right. All right, let's keep going. All right, this one, we'll take the fourth derivative. Well, I got to go through them one at a time. F prime. It's nasty though, isn't it? 8 times 6 is 48, right? X7 minus 14x6. F double prime. I get to get to the fourth one. And it's work though. You know, 7 times 40, 280, 280 and 56, 280 and 56, 336. X6. Wow, it's going to be a nightmare. Minus 6 times 14 is 60 and 24, 84. X5. I got to get the third derivative. And I got to get my grade school arithmetic out. 1800, 180, and 36. Let's see, 8, 9, 10, 11, 10, 2016. X5 minus, I think I can do this in my head, 420. All right, so let me just make sure I'm doing this okay. I'm gonna work over there. And I'm not even there yet. I gotta do the fourth one, right? Now remember, we don't put 4 hash marks down. We write F and we put a little parentheses there saying the fourth derivative. Well, it's gonna be what? 10,000. 5 times 16 is 50 and 30, 80. So 10,080. Minus 1680. And now we have to evaluate this at 1. 10,080 minus 1680. I got to do that arithmetic, don't I? Well, the 80s cancel off. So basically I have 1600 minus 10,000, which should be 8,400. Granted, kind of nasty, but grade school arithmetic for the most part. All right, so I'm up 7. Let's go to 8 now. 8, it's like a nightmare. What do they want? The second derivative. I want to point out this is a function h, which is a function of w. So really it's going to be dh dw, right? Let's write this down. Let's write down h prime w. And what do you get? Well, the derivative of e to w is e to the w. And you get root w. And I'm getting a little better at derivatives because just from practice in front of you. And then it's going to be e to the w times the derivative of the root of w, which would be 1 over 2 root w. That kind of nasty looking. There's no doubt about it. I'm gonna factor it. And again, we got to get to the second derivative. So e to the w comes out. And I'll write this over here. Yeah, I really have to factor it. But root w plus 1 over 2 root w. I got to keep going. And someone said, why do you do so much work? Well, for one thing, I do work so I can accomplish a task. It's going to be 2 root w. Then what do you got? Well, this would be 2w then, plus 1. Boy, that's a lot of work. I can take the second derivative now. Now, I'm not saying that you did this. I'm saying I'm doing this. And we'll look at the answer key later. So I'm going to say the first function, e to the w, its derivative is e to the w times the second function plus e to the w times the second function's derivative. That doesn't look too bad to me. So I have to do the square of the bottom, right? So that's 4w. Take the bottom to the top, 2 root w, times the derivative of the top, which is 2, minus the top, 2w plus 1, times the derivative of the bottom, and the derivative of the bottom is going to be 1 over root w. That wasn't so bad. By the way, I'm not going to simplify it. And so why is that? I just want to get h double prime of 1. Looks easy. A. I'm doing term by term. I'm doing this term here. Times 2 plus 1, 3 over 2 plus e to the 1, right? The bottom is 4. What do you get on top? 4 minus, again, w is 1. You get 2 plus 1 is 3. And 3 times 1 is 3. That's not bad. Gonna keep going. This is going to be 3 halves of an a plus 1/4 of an a. What's come denominator? 4. 3 halves would be 6/4. 6 plus 1 is 7/4 of an a. Mistakes happen. That's why we want to give you a K. Wow. We did okay. All right. Let's read it. It says, which of the following functions satisfy that the kth derivative of x equals 0 for all k greater than or equal to 6? Let's talk about this. Let's do easy ones first. Let's this guy over here. If you take this guy's derivative, first derivative would be 3x squared, right? You get the idea. The second derivative, well, maybe I should write these down for you. Kind of a scratchy little work. I'm going to do b down for you, b. So f prime would be 3x squared. F double prime would be 6x. F triple prime would be 6. I hope you realize that F4 forward would be 0. So I'm going to say this guy definitely produces 0 derivative once you get up to 4 and further. All right, I'm going to get my eraser out. I'm going to erase this nonsense over here. I'm going to look for another easy one to do. I'm going to look at but letter D. And what's D? Well, it's 5 minus x to the 6. So f prime, what would that be? Let's take a look. That'd be minus 6x 5, right? That's not bad. F double prime, that's going to be minus 30x4. I think you get the idea. That's minus 120 x cubed. By the way, they didn't ask you to do it. I'm just saying I can do it. That's all I'm saying. Minus 360, right? x squared, f5, that's going to be minus 720x. The sixth derivative will be minus 720. Would that be agreed? Well, you know what? That's not zero. I'm not going to circle that. That's going to get crossed off. All right. I think I might be getting better at this though, by just doing those two little examples over there. I'm going to say F would fit that description, right? Right. 'Cause again, the 8x squared would just disappear pretty quickly, right? But the 6x5, once I get to the fifth derivative, maybe I should write that down for you. Right. So the 8x squared definitely disappears pretty quickly. But the 6x5, let's put this one down. I'll just write derivatives down. So it's going to be 30x4, 120x cubed. Again, this is F, this is F prime, this is F double prime. Then 360x squared. You get the idea, right? 720x. When I get to the fifth one, I get 720. Say it's 610. This one satisfies it. Let me get my eraser out. A lot of stuff being written down over here. And you can maybe do it in your head. Who knows? I'm going to look at the root of x now. Three has, right? This one's not going to disappear. I'm always going to get x to a power. Close it off. Let's do x to the 9/5 then. Let's see what happens there. I'm going to erase this business here, okay? Let's see, x to the 9/5. It's right over here, f of x. Take away 1 from 9/5 would be 4/5, right? F double prime x. Let's see what you get there. 36 over 25, right? Minus 1/5. Well, again, I realize I'm in the same loop over here. The power of the exponents, it's never going to disappear, by the way. So I can cross this one off now. All right, we'll get my eraser out. Again, homework takes time. We want you to put the time and effort in. Now, I realize that these first two terms are going to disappear pretty quickly, especially when you get to the sixth derivative. Let's talk about the x to the minus 1 now. What happens over there? Minus 1 times x to the minus 2, f double prime. This would be 2x to the minus 3. That's not going to disappear either. So this one gets crossed off. So there's only two. Let's see what their answer is. They say there's only two. X cubed minus 3 and 8x squared plus 6x5 are the only ones. All right. Let's take a look at this one over here. It says find the vertical acceleration at time t equals 5 minutes of a helicopter whose height is, so they give me a height function. All right. So height function, they give it to me. And I'm going to just talk about derivatives now. So dh dt is going to be the change in height with respect to time. And this was known as a vertical velocity. So it's a velocity, but it's vertical. This is a vertical function up here. The next thing is going to be the second derivative. Oops. Give me a second here. The second derivative is going to be the acceleration. It's vertical acceleration. Well, I got to take the derivative then, right? So let's put this down. This is equal to h prime. And this is h double prime. So let's write h prime down. Fairly simple to do. That's going to be minus 9t squared plus 600. And h double prime is going to be minus 18t. What do they want to know? They want to know h double prime at 5. We'll put the units down later. So it's going to be minus 18 times 5, which is going to be, let's see, minus 50 and 40, minus 90. Let's read this thing. And this is in minutes. This is per minute. And the height is in feet. So this is feet per minute squared. Look at your key. You got it. All right, let's go to number 11. Wow. This was going to be tough. Let's get that, well, same question almost. All right. It says at time t equals 5 minutes of the helicopter whose height is given as, the velocity is given as that. I got that covered. The acceleration is the second derivative, minus 18t. I'm kind of just reading it. And I want you to read it too. So they give me the height function. They give me the velocity function. And they give me the acceleration function. All right. So they say, you know, the acceleration at 5 is minus 90 feet per minute squared. Let me see if I can understand at least the story. The derivatives are pretty easy to come up with. That's 300 minus 9t squared. And then the derivative of that would be minus 18t. And they're telling me that h double prime, let me write this down for you. H double prime at 5 is really the function a evaluated at 5 is equal to minus 90. And that seems to make sense because, 5 times minus 18 is minus 90. And that's feet per minute squared, right? So consider the graph. I'm seeing the graph over here. I want to point out what the graph is going to be. I'll kind of read it to you. This axis is time, and that is the acceleration appears. All right. So what are they saying at 5? This is where 5 is about. Trace it down. Okay. Yeah, I'm kind of seeing it. It looks pretty right to me. All right. Consider the graph. Right. Since the velocity is positive in this time interval, does the graph show that the helicopter is slowing down during this period? Circle yes or no. Or speeding up, I guess, right? So let's think about it. All right. So I hope you realize that the acceleration during this time period, right, that we're looking at is always going to be negative. So what is it doing? It's definitely slowing down, right? It's definitely slowing down at that point. Now, of course, I'm going to say over here, it says, I got to keep reading it to you. But the reason I want to get to their question, they say circle yes or no. I'm going to say definitely, it is definitely slowing down. All right, definitely slowing down. Acceleration is negative. All right, so it says circle one of them. I'll circle it. And I'm going to circle yes, it's slowing down. All right. Now, let me read what they got in the blue area. They say as the acceleration helicopter is negative, the velocity helicopter must be decreasing. Yeah, it's slowing down because the velocity is positive. Let's go for this over here. Now, I wonder what they're putting that down. I want to see if I can understand it. So what's the velocity function? This is important you know about this. H of t is equal to 300 t minus 3t cubed. I want to point out if I was doing this is like a 119 question. When is it positive, when it's negative? I'm going to factor out a 3 and a t. And what would I get over here? Well, what would I get? I would get, let's see, 100 minus t squared. All right, did I do that right? Let's see, 100t, 300t. Yeah. So let's see what they say because last positive between this t's over here. Let's put this down for you. And I'll write this over here. Oh, you know what? I'm sorry. That's not the velocity function. I copied the wrong problem. Sorry about that. I'm looking, but I'm not reading. So velocity function, the velocity function is this over here. All right, I'm going to try to factor that and find out when it's 0, right? That's what you did in Math 119. And so 300 equals 9t squared. I'm trying to put the velocity 0, by the way. Divide both sides by 9. That's be 300 over 9t squared. And now t is going to be equal to, I got to do t, right? It would be plus or minus the square root of 300 over 9. And I think I can do that. Plus or minus the square root of 300 would be 10 root 3. Oops, sorry about that. And the bottom number is 3. So over here. So minus 10, 3 over 3. And over here would be 10 root 3 over 3. Simple sign analysis, what do you got over there? Well, if you plug in, 0, what do you get? You get positive number. That means positive velocity. If you go past that, you get negative velocity. Seems kind of strange. What does negative velocity mean? It's going down. Here where it's going up. And this where it's going down. And this where it's going down. I got to be honest with you, though. I don't really want to think we talk about negative time. So I'm going to simply say time typically for most people would start at 0. So I'm going to say when the clock is ticking between t is 0 and t equals 10 root 3 over 3. I'm going to say if we're looking at that, we would definitely be talking about a helicopter's going up, but it's slowing down. All right. And that's all they're saying over here. That's all it's saying over there. All right. But it is going up. It is going up, but it's slowing down as it's going up. All right. That's about it. It was a long one, but again, it's manageable. And most of these problem sets are manageable for students.